Alright, I want to do a video. We're still doing graphing, but I want to kind of include some examples of different type of questioning and also look at exponential regression. We did linear regression, but I want to look at exponential regression using your calculator. Okay? Alright, so let's look at this one. We did one like this last lesson, and we're going to use our calculator to create our table with our points. But let's identify some of the main things about this graph and also look at the transformations from the parent graph. Remember, the parent graph is y equals b to the x, okay, where a is 1. All right, the transformation we have here, where on a parent graph, if I plug in 0 for x, then anything to the 0 power is 1, so y would be 1. So on the parent graph, your y-intercept's right there. But let's look on this equation. We can see that instead of x, it has x minus 4, all right? And if I was to put that in a calculator, I would put it in parentheses. So remember, that's going to be like on any of the other transformations we did, that shift is going to be the opposite of what it's saying. So instead of going to the left 4, and when we bring it out of opposite world, we're going to go to the right 4, okay? And then this would be my vertical shift, so it means I'm going up 1. This is also my isotope, so it means it's flattening out at 1. If you will look, your B is 2, so we have a growth factor. So our graph's going to be going left to right. It'll be increasing. All right, so it says graph for the isotope with a dotted line. So the isotope is 1. So we'd have a horizontal line going across the y-axis at 1. So it says then graph at least 4 points. So y'all were doing this on Delta Math, so you would have to click your points. So we need to find 4 points. All right, so we know that it's going to be looking like this, and so it's going to be kind of flattening out at 1 and then crossing. So let's see what our y-intercept would be. So when I replace x with 0, I get 2 to the 0 minus 4. So I get 2 to the negative 4 power. So that would be 1 over 2 to the 4th plus 1. So this would be 1/16 plus 1. So that would be 15 over 16. Okay. Oh, sorry. 17 over 16. So it's a little bit more than 1. So this graph is going to be going. Let's try, since this is 4, let's try 4. So 4 minus 4 is 0. So that would be 2 to the 0 power is 1 plus 1. So my y would be 2. And you can put this equation in your calculator into y equals and look at your table. If I say 5 minus 4 is 1, so 2 to the first power is 2, plus 1 would be 3. If I plugged in 6, 2 to the 6 minus 4 is 2 squared, which is 4, and then we add our isotope 1, so it'll be 5. We did 7. 7 minus 4 is 3. So 2 to the third is 8, plus 1 would be 9. That's about as far as we can go on the graph. So let's graph that. 4, 2, 5, 3, 6, 5, and 7, 9. So we're looking like this. Okay. All right, this says find the equation of the exponential function. Now remember, from a table you get your whole factor, not the rate, the whole factor, your b. Okay, so looks like we're multiplying by 4 every time, so that's my b. And then my initial value is going to be my y-intercept, so my initial value is 2. So my function would be y equals 2 times 4 to the x power. And if I plug in 2 times 4 to the 0, does that equal 2? Well, this would be 2 times 1, so it does equal 2, and it checks out. All right. Okay, this is exponential regression. Okay, we've done linear regression. Okay. But we do this in the calculator. So I want to go on over here to show you these steps for doing linear regression. Okay. So it says the accompanying table shows the number of bacteria present in a culture over a 6-hour period. So here's X is hours. So over each period, each hour, they take a measurement. Where X is time in hours, and Y is the number of bacteria. It says write an exponential regression equation for this data set, rounding all coefficients to the nearest thousandth, so what, that's 3 places out, and determine the number of bacteria present after 14 hours to the nearest whole number. Okay, make sure you read those directions so you know where to round your answers. All right, so the steps here, I know it's been a while since we've done, this is the steps for linear regression. Same steps, the only thing is right here where you would choose number 4 for linear regression. We're going to go to number 10 for exponential regression. Okay, so first we're going to hit the stat key, hit stat. If you've got any, okay, hit stat, and then we're going to hit enter for edit, because we're going to enter our data. So most of you in your calculator will probably have some data already in there. The way you clear it, and this is real important, the way you clear it is to arrow up where your cursor is highlighting the L1 or the L2. So let's highlight L1, hit the clear, and then go down. So that should clear it out. So we're going to arrow up to L2, clear, go down. All right, so we've got L1 and L2 clear. So we're going to enter X into L1 and Y into L2. So 0, 1, 2, 3, 4, 5, 6. And then you arrow to the right and you enter in your numbers for each of those hours. So 1374, 1486, 1719, 1836, 2025, 2228, 2572. Okay. All right, so you've got your data in the L1 and L2. So it says enter your X values in L1, Y values in L2. Then hit stat again. and you're going to arrow to the right to where it highlights calc, C-A-L-C, for calculate. And you're going to arrow down until you get to number 10, which is exponential regression. And you're going to hit enter 5 times. And it's going to give you y equals a times b to the x, which is our form, right? So a equals 1364, and it said round your coefficients, so the numbers in front of, to the nearest 1,000. So we're going to do 0.098. And then B is going to be 1.107. If you see a R there, that's your correlation. And the closer you are to the number 1, the stronger the correlation. And this is 0.997 or 6. So this has a strong correlation, strong positive correlation. Okay, so now I can write my equation. Y equals 1364.098 times my factor. It's the whole thing. You don't have to worry about rate or anything. And they want us to find the nearest after 14 hours. So we're going to put 14 there. 64.098 times 1.107 to the 14th. So you're going to get 5,661. It said nearest whole number, so we're going to leave it at that because it was 0.2. That would be my nearest whole number. So in 14 hours, that's how many cultures we'll have. Okay. All right, let's do one more. Okay, you're going to hit stat, enter, clear your L1 and L2, go arrow up to L1, hit clear, arrow down. Same thing for L2. So now you're going to enter this, your X under L1 and your Y under L2. So 0, 1, 2, 3, 4. Then arrow over and enter your Y values. 13,073, 11,333, 9,204, 7,551. Looks like this is decreasing, isn't it? Okay, because they're looking at the value of a car over time. Initial value was this at 0. They want them near to the roundest. Okay, so now we're going to hit stat, arrow over, and we're going to calculate and go to number 10, exponential regression, hit enter, then hit enter 5 times, and we get A is 14,583.12, and we're rounding to the nearest 1,000. And B equals 0.857. And our regression was negative 0.97. And this is depreciating, right? So it has a strong negative. Sorry about that. So yeah, when you've got a decay or decreasing the car value, you'll notice that your correlation is a negative. But in this case, it was close to the absolute value 1, so it's a strong negative. Now, if I had something like negative 0.3, that'd be a weak negative correlation. All right, so they're wanting us to find the value in 8 years. So our equation is going to be y equals 14,583.123. And I'm just following what they said as far as writing my numbers to the nearest thousandths. Times 0.857 to the 8th power. So we're going to have 3.123 times 0.857 to the 8th. So the value in 8 years would be 4,243 and 20, round it to 24 cents. Okay. All right, so y'all have got some practice to do on that, some additional practice. All right. Okay, thanks.